Question says 0.25 mole of hydrogen chloride was dissolved in distilled water and the volume made up to 0.50 dm cube. If 15.00 cm cube of the solution requires 12.50 cm cube of aqueous sodium trioxocarbonate 4 for neutralization, calculate the concentration of the alkaline solution. Solution. According to the question, this is a neutralization reaction, and in a neutralization reaction where we have the acid and the base, the product formed is always salt and water, but here the base is sodium trioxocarbonate 4. So when the base is a carbonate compound, the product will always include carbon dioxide. So in this equation now we'll be having HCl, which is the acid, plus the base Na2CO3 to give us salt. So the salt formed there is going to be NaCl, sodium chloride, plus water, and then carbon dioxide. So let's see if the equation is balanced. Let's begin with sodium. We have 2 atoms of sodium present here and we have 1 in the product side. So let's add 2. Now we have 2 atoms of sodium as well in the product side. So let's continue. 1 atom of carbon in the reactant side. For the product we have 1 as well. Carbon is balanced. Oxygen, now we have 3 atoms of oxygen present here. So let's check. We have 1 plus 2 here, that's 3. So 3 atoms is also present in the product side. So let's come back to hydrogen. We have 1 atom of hydrogen present in the reactant side, and in the product side we have 2. So we need to add 2 here to make it balanced. So here we have 2 atoms of hydrogen present and 2 atoms as well in the product side. So for the chlorine, this 2 is going to affect chlorine as well. So we have 2 atoms of chlorine present in the reactant side, and in the product side we are having 2 as well. Hence we can say the equation is balanced. Then let's proceed. In a kind of volumetric analysis question like this, the formula which is commonly used is CAVA over CBVB, which is equal to NA over NB, and that's the formula we'll be using to solve this. Let's write out the values we are given from the question. Ca. From the question, Ca is not given directly, so let's assume Ca is unknown. We're still coming back to this. Va is given to be 15.00 centimeter cube. Cb is unknown, and that's what we are being asked to calculate. Vb is 12.50 centimeter cube. Na, so our Na is gotten from the equation, which is the coefficient of the acid present, and the coefficient here is 2. So Na is 2, and Nb, coefficient of the base as well. So the coefficient here is 1. We have 1. Now we can't proceed here because we have 2 unknowns. We have Ca not known yet and Cb not known. But from the question, we are being made to know that 0.25 mole of the acid is present in 0.50 dm cube, and we need to know the concentration of the acid in mole per dm cube. that is the moles of the acid that will be present in 1 dm cube. So we can get that by using the relationship saying 0.25 mole HCl is present in 0.50 dm cube. So how many will be present in 1 dm cube? Then we say x moles of HCl is present in 1 dm cube. Here S equals 0.25 moles HCl times 1 dm cube divided by 0.50 dm cube. And we have that to be 0.5 moles of HCl. So that is 0.5 moles of hydrogen chloride is present in 1 dm cube, which simply means that Ca is equal to 0.5 mole per dm cube. So now that we've gotten Ca, then it remains Cb, and that's what we are being asked to calculate. So to get Cb, we'll be making Cb the subject of the formula. So we'll say Cb equals CAVA times NB divided by VB times NA. So let's substitute the value. So we have 0.5 mole per dm cube times VA 15.00 centimeter cube times NB, which is 1, divided by VB. Our VB is 12.50 centimeter cube multiplied by NA, which is 2. Here we have 7.5 divided by 25 mole per dm cube, which is equal to 0.30 mole per dm cube. And that answers the question. So we've gotten Cb to be 0.30 mole per dm cube. So with this, we've calculated the concentration of the alkaline solution, that is sodium trioxocarbonate 4 Na2CO3, which is 0.30 mole per dm cube, and that's going to be the final answer.